STEM adventure. Revision notes. OCR A-level physics. Forces in action. Firstly, for this topic, we need to understand the different types of forces that act in a number of situations. Objects on slopes is a favorite, as are objects hanging under tension. So the direction of forces like weight, normal contact force, upthrust and tension, etc. need to be known. Also, how to resolve these forces into components will be critical for situations covered later in this topic. We also need to remember that if there is a resultant force, any object will accelerate. The equation F equals ma links the resultant force, mass and acceleration. You will need to apply this basic understanding to more complex calculations. For any object in translational equilibrium, there is no resultant force in any direction. So we can resolve in any direction and the resultant force will be zero. For objects on a slope, it is normally advantageous to resolve along the slope and perpendicular to it. For a hanging object, we would normally resolve vertically and horizontally. For this example, we need both directions so we can solve simultaneously. Other examples may come up, so just look for directions to resolve in that either allow the problem to be solved simultaneously or that will allow forces to be calculated directly. Another typical situation where you will be asked about the effects of forces is for objects falling under the influence of gravity and air resistance. Here we need to remember, as an object falls, the force of gravity on the object, the weight, remains constant, but the drag, air resistance, increases as the object falls. As the drag increases, the resultant force reduces, so the acceleration reduces and the increase in the velocity decreases. This continues until the drag is equal to the weight. The resultant force is therefore zero. At this point, the object has reached its terminal velocity. For terminal velocity, the velocity is constant, that is, acceleration is zero. Forces can be turned into turning forces by having them act about a pivot. This moment of a force is defined as the force multiplied by the perpendicular distance between the line of action of the force and the pivot. This equation and the equation for torque are in the data book. Torque is usually applied to a couple of forces causing an object to rotate. A couple being defined as two opposite forces that give a turning effect but no resultant force. Remember, the principle of moments can be used to structure questions for objects in equilibrium, so calculating the clockwise and anti-clockwise moments. The center of gravity is the point through which the force of gravity for the whole object seems to act. Take some time to remember these key points. The equations for density and pressure are given in your data book. Just make sure you have remembered what all the symbols mean. Archimedes' principle states that the upthrust due to an object partially or fully immersed in a fluid is equal to the weight of the fluid displaced by the object. Finally, the pressure difference in a fluid is dependent on height, density, and strength of gravity, and ultimately due to the pressure above the fluid coupled with the movement of the particles in the fluid. Take time to memorize these and all the concepts from this topic. Remember that all our resources, including revision notes, flashcards, multiple choice questions, and past paper questions, are available on our website.